These are the notes for section 2.4 part 1. They are over horizontal and vertical lines, and then we're also going to talk about parallel and perpendicular lines. Some of these things might be a little bit of review to you, but I think we could all use some practice. You want to make sure and take these notes on graph paper, and you might want to pause right now to write down what's on the screen right now. Alright, so the first thing we're going to talk about is horizontal and vertical lines. So with horizontal and vertical lines, what we really want to look at is their slope and what their equation looks like. So I'm going to kind of split my paper in two right now. I'm going to talk about horizontal lines really quickly on the left side and vertical on the right side. I'm going to draw a set of axes for each. And then for our horizontal line, let's draw a line. I want you to go up to 2 on the y-axis, and I want you to draw a horizontal line right there. And I'm going to put a dot or a point right here at 1, 2. And then I'm going to go 2 to the right and put another one at 3, 2. So pause if you need a second to get that down. If we look at those two dots, if you think about trying to find the slope between those 2 points, you need the rise and the run. Well, to get from one of those points to the other, there's no rise. They're on the same level in terms of height or y value. So our rise in this case would be 0. And between any 2 points on that line, the rise would be 0, right? You don't go up or down to get anywhere else on that line. The run between these 2 points is 2. It could change depending on what points we put on there. But no matter what, 0 divided by a real number is 0. So what we found out about that horizontal line is that the slope is 0. And if we wanted to write an equation of that line, here's what I always think to myself. This line goes right and left forever at the same y value, all right? It's at the same height up or down. We don't really care what x is, but it does cross the y-axis. So it has a y-intercept. It does not have a slope. The slope is just 0. If we tried to write an equation, it would be like y equals 0x plus our y-intercept, which in this case is 2. 0 times anything is just 0. So in this case, I always remember it hits the y-axis, so it has a y in the equation. The equation for this one is just y equals 2. That's it. So horizontal lines have really simple equations. Let's go ahead and take a look at a vertical line. So what I'm going to do on my vertical line is I'm going to go to -2 on the x-axis, and I'm going to draw a vertical line right there. If I take any 2 points on that line, so I'm going to look at the points -2, 1 and -2, -2. I'm going to look at those 2 points, although any points would work for this. If we look at, like we did last time, our rise and our run, well, between those 2 points, our rise is 3, right? It goes up 3. But our run is how far we go left to right, and we don't go left or right at all. It's the same distance over on the x-axis. So our run in this case is 0. Now hopefully you remember this, that anything divided by 0 is undefined. And you might remember Slope Dude on this graph too. Remember he yells undefined as he goes down the cliff. So the slope of this line is undefined. Vertical lines have a slope of undefined. But a mistake I see people make a lot is that they say the equation of the line is undefined. This line still has an equation, all right? It doesn't touch the y-axis, so we don't really care about y, but it does touch the x-axis. So all we need to know about this line is that x is -2. No matter where you go on this line, your x value is -2. You could fill in as many points as you want, and no matter what, that x value is going to be -2. So our equation is x equals -2. There's no y in your equation, which I know is kind of funny. Horizontal and vertical lines have funny equations. So the way that I remember all of this stuff about horizontal and vertical lines is a little acronym, and it is HOY. Oops, I want to do that in black. HOY, H-O-Y, although you'll find out it's not really an O. VUX. HOY VUX. So here's what these letters mean. The H in HOI stands for horizontal. Horizontal line straight across. The O in HOI, it's actually not an O, it's a 0. So it means that the slope is 0. And the Y in HOI means that the equation is in the form y equals some number. You know, it depends on where it hits the y-axis. So HOI, horizontal lines have a slope of 0, and the y means that the equation looks like y equals some number. For vertical lines, so the V in VUX stands for vertical. The U is the slope. The slope of a vertical line is undefined. And the equation of the line is written in the form x equals some number. So that's how you can remember these things about horizontal and vertical lines. HOI, VUX. HOI, VUX. So let's do an example now. We're going to graph something. For example, use slope-intercept form to graph f of x equals 3. Now, if you get scared by this f of x equals 3 thing, just remember that f of x is basically like y. It's our output. So it's really just saying y equals 3. So if you go back and think about HOI, VUX, when you see the y equals, you know it's in this part of HOI, VUX. So this is a horizontal line. Okay, I knew it was in HOI because of the y. So a horizontal line, the slope is 0, y equals 3. So I'm going to go up to 3 on my y-axis, and I'm just going to draw a horizontal line right through that. That's it. It's really simple. You just have to kind of remember to keep it straight. All right, let's do another example. Example, we're going to graph x equals -2. So if we think about HOI, VUX, when I see the x, I know it's in VUX. So it's a vertical line, and it's where x is -2. So I'm going to go on my x-axis to -2, and then you're just going to draw a vertical line. Whoa, that was a bad vertical line. You're going to draw a vertical line using a ruler. I don't have a ruler up here, so I can't use one. But you should have a ruler. So we're going to draw a vertical line right there. All right, we're about halfway through these notes. So we're going to do another example. I want you guys to try it on your own. I want you guys to try graphing x equals 4. Make a new graph for me. X equals 4. Pause this, try it, and come back. All right, so now we're going to find the slope of each of these lines. I'm actually going to go through and get these variables by themselves, but you don't even have to do that much. So on this first one, I'm going to get this y by itself. So I'm going to subtract 2 from each side. I'm left with 3y equals 12. And then we can just divide by 3. And we're left with y equals 4. So when you see just the letter y in your equation, if you only see one letter in your equation, just a y or just an x, you know it's either horizontal or vertical. It's one of these crazy lines. Either has a slope of 0 or an undefined slope. So if we see that y, we want to think, well, is that part of the HOI or the VUX in HOI, VUX? And it's part of HOI, which means it's a horizontal line. And remember slope due on a horizontal line, he says this is 0 fun. So in this case, our slope is 0. If we look at our other equation, 2x equals 10, well, I can get that x by itself. I just divide by 2, so x is 5. And then if I look at HOI, VUX, I only have an x. So I'm looking at the VUX part of that, which means it's vertical, straight up and down. And remember, on a straight up and down line, slope dude says undefined. And you also know it's undefined because of that u in VUX. All right, so now we're going to move on to talking about parallel lines and perpendicular lines. Pause this if you need more time. All right, so I'll go ahead and fill these in, and then you guys can pause it if you need some more time to write this down. So the first thing we want to know is that parallel lines have the same slope, the exact same slope. So for example, let's write down 2 equations of lines that would have the same slope and therefore be parallel. maybe something like y equals negative 1/2 x plus 7 as our first line, and y equals negative 1/2 x minus 8 as our second line. Those have different y-intercepts, positive 7 and negative 8, but they have the exact same slope of negative 1/2, and that means those lines are parallel. Remember, slope means the steepness of a line. It measures the steepness. So if two lines have the same steepness, they're never going to touch, which means they're parallel. Perpendicular lines, on the other hand, they have slopes that are something called opposite reciprocals. So opposite reciprocal, it basically means that it is a fraction. I mean, you can write any number as a fraction. Opposite means opposite sign. Reciprocal means flipped over. So let's look at two examples of lines that would be perpendicular and have opposite reciprocal slopes. Let's say our first line was y equals 3/2 x plus 7. So the slope of that line is positive 3/2. And our other line, to make that slope be the opposite, I need to make it negative, because our first slope was positive. So if two lines are perpendicular, one line has to have a positive slope, the other line has to have a negative slope. And then we also need a reciprocal. So instead of 3/2, our slope has to be 2/3. And then we could have the y-intercept be whatever. I'll make it negative 8 again. It doesn't matter what the y-intercepts are. As long as the slopes are opposite reciprocals, then two lines are perpendicular. So we're going to do some examples where we determine whether lines are parallel or perpendicular. Pause this if you need more time to copy down this page. For example, determine whether the line given by f of x equals negative 3x plus 4.2 is parallel to 6x plus 2y equals 1. Pause this if you need time to write that down. If you're scared by this f of x here, remember, this is just like y equals negative 3x plus 4.2. So our slope here is negative 3. If our other line is parallel, we know it has to have the same slope. So let's write down that other line, 6x plus 2y equals 1. To see if this is parallel, we need to know the slope. So we need this in slope-intercept form. So I need to get this y all by itself. So the first thing I need to do is undo any addition and subtraction. So I'm going to subtract 6x from each side. And I'm left with 2y equals negative 6x plus 1, because that was a positive 1 up there. Now I need to just divide by this 2 in front of the y. I'm going to have to use the heart method on the other side here. So I'm left with y equals negative 6 over 2x. Well, negative 6 divided by positive 2 is negative 3, and I have that x on there. For the other part of my heart, 1 divided by 2 is, I'll just leave that as 1/2. So in this line, if I'm looking at this in slope-intercept form, remember my slope is the coefficient of x, and it is negative 3. These lines have the same slope, so they are parallel. I mean, on the test, I'll have you just write yes or no, but I think in your notes it helps to write down, yes, they're parallel, because then you really remember what you were doing. So I'm going to give you guys an example where I want you to find out if two lines are parallel. So here's your two equations. 8x plus y equals 2, and f of x equals 8x plus 7. I want you guys to pause the video and find out if those two lines are parallel. All right, last example we're going to do together, and then I have one more for you to do on your own. We're going to see if these two lines are perpendicular. So I've got two equations here. One is 2x plus y equals 8. The other is y equals 1/2 x plus 7. And we're trying to find out if these are perpendicular. So remember, if they're perpendicular, my slope should be opposite reciprocals. So the slope of my first line, I can already see it, is 1/2. So I should already be thinking in my head, well, my other slope had better be a negative 2 or 2 over 1 if it's going to be perpendicular. I have to make it the opposite sign and flip the fraction. So let's go ahead and get this y by itself here. I think the only thing I have to do is subtract this 2x from each side. And we're left with y equals negative 2x plus 8. So my slope here is the coefficient of x, which is negative 2. And that's the same as negative 2 over 1. That's the opposite reciprocal of positive 1/2. So the answer to this is yes, these are perpendicular. I have one more for you guys to try on your own. I want you to see if these two lines are perpendicular for me. And when you are done, you are finished with your notes, and we will go over all the ones that I had you try on your own together tomorrow.